Hello everyone, welcome to the last video of this week. We're going to be, there's actually going to only be 3 lectures left, which is kind of nice, and then a final test request, or whatever you want to call it, quiz/test, which will be on the final week before school ends, right? That's in about 2 weeks, so we're about 2.5 weeks left of the semester, so celebrate. Anyway, so what we're going to do is we're looking at solving by elimination today, and we're going to be looking at a variety of techniques for different ways to solve linear systems, which is what this whole unit's been about. And what's nice with math is that we can find different ways that are sometimes and more often more efficient than other ways to go about solving an equation, solving a system of equations, or cracking codes, anything like that. There's always someone who's able to figure out a more efficient way to do the same task. And what we're going to look at right now is a more straightforward way to solve systems of equations. It just takes a little bit of different mindset and some manipulation with the equations. So there's not really too much that we can talk about before actually just diving into an example. So let's just go into an example that we've seen before. Solve the following linear system by addition. So what does that mean by addition? Well, you've kind of used this technique before. Well, maybe not this exact technique, but you've used what we're going to talk about before, and you probably used it back in the first grade. And what we're going to do, we have 2 equations here, so let's make this a little less thick. We have 2 equations here. We've got equation 1, we've got equation 2 down here. I'm not going to worry about making them different colors because it doesn't matter right now. I'm going to stack them. I'm just going to rewrite them over here. So x plus y equals 4 was our first one, and then we have x minus y. I'm going to stack them like this very intentionally. What we're going to do, we're going to pretend this is like one big addition problem, and we're going to treat it like the addition problems that you've done in the past before, right? Where we stack 2 numbers, like 24 plus 48, and you would stack them, be like, okay, we've got to carry the 1 over here, the 2 goes at the bottom, 4 plus 2 is 6, plus 1 is 7. It's the same, this is the exact same kind of premise as what we're going to do over here. And all we're doing at this point, this question itself tells us what we're doing. So we're adding these 2, right? And well, let's see what happens. Let's see what happens if we add these. So x plus x, what does that give us? Well, it gives us 2x. Positive y plus negative y. Well, that's going to cancel them out, and we're left with 0y. One way you can think of that is just 0 times y. But in reality, we usually just don't write anything here, right? Because it's just 0. And then equals, what's 4 plus negative 10? Well, that's just negative 6. So what we have here is 2x equals negative 6. And you might start to see why this is useful, right? We've just automatically, we've pulled out 2 equations which originally had 2 variables to 1 equation now which only has 1 variable, right? And we can solve something that has 1 variable. It doesn't create a weird conundrum for us. We can solve this, right? We can divide by 2 on each side. And what do we get? Well, we get x is equal to negative 3. So there's the x coordinate solution for the system. X is equal to negative 3 at the point where these 2 lines intersect. That's awesome. We've gotten that without having to graph, without having to do any other heavy lifting. We've gotten that. And now how do we get the y component? Well, the y component is just going to come out of, so actually let's label some of these steps here. So this is step 1, stack equations and add. And then step 2, plug in the coordinate to equation 1 or 2. Right? Because if we know that the x coordinate is the same for both of these equations, we could plug it into either 1 or 2. And guess what? We're going to be able to solve for y then, because the same thing, right? We're going to plug it in, and then we have 1 variable to solve for. I'm going to plug it into 1, but you could also plug it into 2, and you would get the same thing, right? You can plug it into 2, you get the same thing. So I'm going to plug it into 1. So let's kind of split this off here. So plug x equals negative 3 into equation 1. And what are we going to get? Well, x is negative 3 is going to go, I'm going to put that in brackets, plus y equals 4. Negative 3 plus y equals 4. Well, how can we get this negative 3 out of here? How can we get it out? We can add it, right? And we get y equals 4 plus 3, and y is 7. So there is our solution to the system. The solution to the system occurs at negative 3, 7. So let's write this over here. Let's write this. Let's do a different color. Therefore, the solution to the system occurs at point negative 3, 7. That's the gist of this. And it just takes some practice to get used to, but once you get it, it ends up being kind of fun, and it's extremely useful for just knocking these questions out of the park. So just a two-stepper. Let's look at another one. And in this one, it's asking us to subtract. So let's do that. I'm going to set these up again. I'm going to set these up again over here. Just actually, you know what? I won't even do that. Let's set it up just as it is over here. We're going to subtract. So the thing that we need to be careful with when we're subtracting is that this subtraction symbol is going to distribute into every single term here in this bottom equation. So we don't have positive 7x anymore. We have negative 7x. So what's 7x minus 7x? Hey, well, that's just 0x. What's negative 5y minus positive 2y? So that would just be the same thing as negative 5y minus 2y. Well, that's just minus 7y. Okay? And then equals what's negative 24 minus negative 10. Negative 24 minus negative 10. So that turns it into a positive, right? So negative 24 plus 10 is wow, am I blanking on that? Negative 14. So we're left with negative 7y equals negative 14. Well, we can solve for this now, right? Negative 7, and we get y is equal to positive 2. So let's plug this in. So we have equation 1 here, we have equation 2 here. Plug into, let's do equation 2 this time. And equation 2, remember, initially, before we subtracted it, everything here is positive. So you're going to take the equation as is. So this is actually, it's still 7x plus 2y equals negative 10. So what are we plugging in? Now we're plugging in y this time. So we got 7x plus 2. I'm going to 7 my 2 for y equals negative 10. Well, what do we get? We get 7x plus 4 equals negative 10. Okay, let's move that 4 to the other side. So we get 7x equals negative 14. Divide by 7, and we are left with negative 2. So there's our coordinate. So let's write that in. Therefore, the solution is, what is it? Negative 2, positive 2. And that's all we need to write for these, folks. So I believe we just have 3 more examples here. And we've covered the system sharing similar terms. I'm talking about similar terms in the fact that there's a lot of similar terms here. 1y and negative 1y. They both have a 1 coefficient in front of them. 1x, 1x, they both have a 1 in front of them. 7x, 7x, they both have a 7 in front of them, right? So those are similar, but what happens when things don't stay similar? And this one, it's kind of actually along the same lines as example 1 and 2 here. We do have similar terms here, but we need to manipulate this a little bit to get this in a form that is more useful. Because if you notice up here, our x's and y's were all on the same side, and our constants were on the other side. Our regular numbers were on the other side. Over here, it's mixed up. There's a variable out here, constant here, variable over here, variable here, variable, constant over here. So we need to rearrange this. We need to rearrange to get variables on one side and constants on the other, and constants on the other, right? So let's do that. So instead of negative 7x, I'm going to leave that on this side. So negative 7x, but I'm going to pull that 5y to this side. So I'm going to actually subtract 5y. And then I'm going to move the 31 to the other side. So I'm going to add it. So there's equation 1. And equation 2 is going to be, well, I'm going to move that 3x over to this side. So we get negative 3x. And notice that I'm stacking my variables, right? It'd make things a little bit more confusing if I put my x under the 5y. And then we had negative 5y equals, I'm going to move that negative 19 to the other side by adding it. Okay, so there's equation 1 and 2. I'm just going to label them a bit smaller. Now what can we do here? What can we do to get rid of one of these variables? So we need to somehow choose either subtract or to add in such a way that it will get rid of either y or we'll get rid of our x's. Well, there's really only one way to do this, right? Our y's share the same term in front. So these are the only ones we can get rid of. But how do we get rid of this? Are we going to add or subtract? Well, if we add, that won't solve anything, right? Because if we add these, this is just negative 5 plus negative 5, which is just negative 5 minus 5. But what if we subtracted? If we subtract this, then this term here becomes negative 7x. And I'm going to kind of group these to show you what's going on. So you have negative 7x minus negative 3x. And then we have negative 5y minus negative 5y equals 31 minus 19. 31 minus 19. So what's this going to simplify to? Well, negative 7x minus negative 3x, that's the same thing as negative 7x plus 3x, which is negative 4x. minus 5y minus minus 5y, that's negative 5y plus 5y, which is 0. 31 minus 19, 31 minus 19, it's just 12. So we're left with negative 4x equals 12. Divide through, and we're left with x equals negative 3. So let's go and plug this in. I'm going to plug in to equation 1. And again, it doesn't matter which one you do it. So we got negative 7 times negative 3 minus 5y equals 31. Negative 7, that's 21 minus 5y equals 31. I'm going to move the 21 to the other side, which means I'm going to subtract it, which gives us negative 5y equals 10. Divide by negative 5, and we got y equals negative 2. Okay. So we could say, I'm just going to move all of this up. Oops. So therefore, solution is negative 3, negative 2, right? So only 2 more examples here. And now we're going to break the script. We're going to break the script of having similar terms here. So look at this one. We have 4x, 8x, 3y, 9y, and 15. Nothing is similar here, right? We can't do any addition or subtraction here that would get rid of all our variables. We can't do anything like that, right? 3y, no matter what we do, 3y plus or minus 9y won't get us rid of y, and 4x plus or minus 8x will not get rid of x. So we're at a kind of crossroads here. What are we going to do? Well, we can multiply one of the equations to get a term that is similar to the other equation. You could also divide. Multiplying is generally better because you won't get stuck with fractions. So let's think about, well, what can we do to this equation to get either 4x to 8 or 3y to negative 9 or 3y, or actually just 3 to 9, 4 to 8 or 3 to 9? What can we do? We can do 2 things right here, right? We can either do 4 to 8, in which case we multiply everything up here by 2, or we get 3 to 9. I'm going to choose the easier route, which is just doubling everything. So what I'm going to do, I'm going to take equation 1 and multiply by 2. Okay. So what we're going to get is kind of like this kind of idea. So 2 times 4x plus 3y equals 2 times 15. So just everything multiplied by 2. What do we get if we do that? Well, we get 8x plus 6y equals 30. There's equation 1. And now notice that we have an 8x here in equation 2. We can do something with that. So let's throw equation 2 down here. We got 8x minus 9y equals 15. And the question I'm going to ask you is, should we add or subtract these? Should we add or subtract these equations? Because we want to get rid of one of these variables. And the only way we can get rid of them is if we subtract, right? Because we have 8x minus 8x. So we have 0x. Positive 6y minus negative 9y is plus 9y, which is 15, plus 15y equals 30 minus 15 is 15. So we get 15y equals 15, divide by 15, and we get y is equal to 1. So there's one solution. Let's plug into, and you could either do equation 1 as is, or you can do equation 1 as you did down here. Both of these will work. Or you can do equation 2. Let's do equation 1 just as is. Okay, so we have 4x plus 3 times 1 equals 15. We have 4x plus 3 equals 15. 4x, I'm going to move that 3 to the other side by subtracting, equals 12. 4x equals 3. And there's our solution. So therefore, solution is 3, 1. 3, 1. One more, I promise, then we're good to go. Solve the following linear system using either addition or subtraction. So what's different about this one? Give you a moment to think about it. You can pause the video. There's nothing here that's common. We can't do anything to 2 to get it to a 3. We can't do anything 5 to get to a 4, and vice versa, 4 to a 5 or 3 to a 2, right? So find a common multiple. Find a common multiple of variables and multiply both equations. To achieve that multiple. To achieve that multiple, right? So I will separate these two. I'm going to call this one equation 1. I'm going to call this one equation 2. Let's do 1 first. What's a common multiple that we can get both of these? Because you can get a common multiple between 5 and 4. You can also get one between 2 and 3. Again, I'm going to choose the easier route here. I'm going to choose to get one between 2 and 3 because I know a common multiple between 2 and 3 is 6. So how can I get this to be 6x? Well, I'm going to multiply everything here by 3. Because if I only multiply this, it's not being fair to the rest of the terms in our equation. So we have to multiply everything here by 6. So let's choose, so we got equation 1, multiply by 6. Sorry, multiply by 3. Oops. Multiply by 3. And again, we're trying to get one of these variables to be the same number. We just want them to be the same number. In this case, we want a 6 in front of here. We want a 6 to get in front of our x's. So here we go. Here we go. So we're going to multiply by 3. So we're going to do 3 times 2x minus 5y equals 3 times negative 19. So we get 6x minus 15y equals, and I actually don't even know what that is, 57. 3 times 19, yeah, negative 57. So here's our new equation. New equation 1. Let's do this with the other one. So we did it in blue. And what do we need to multiply equation 2 by to get 6 for x? Well, we need to multiply by 2. So we get 2 times 3x plus 4y equals 2 times 29. So we get 6x plus 8y equals 4. Oops, that looked like a 2a to me. 29 times 2 is 58. And here's our new equation 2. Okay? Makes sense so far? We're good. So let's stack these equations now. Let's stack these equations. I'm going to just put 1 on top of 2 just to be kind of like normal with everything. So we have 6x. Actually, let's write a little statement here. So stack new equations and solve. Okay? And what are we going to do with this? Okay, so we have our first equation here. We got 6x minus 15y equals negative 57. And then we had 6x plus 8y equals 58. And let's solve. So what are we going to do? What are we going to do with this 6x here? We're going to add or subtract it with this bottom one? Well, we're going to have to subtract it, right, to get rid of that 6x. So 6x minus 6x, that's just 0x. Negative 15y minus positive 8y, that's negative 15 minus 8, which is negative 23y. Okay. Equals 57. Negative 57 minus 58. Minus 58, oops. We plug that in. Come on. I'm going crazy. 115. 115. Okay. My voice cracked. So we get negative 23y equals 115. Let's get rid of that negative 23 by dividing it out. And what do we get? What do we get? I have to plug out a calculator for this. 115 divided by negative 23, we get 5. Negative 5. So we're almost home free now. We're almost home free. And you know what? So plug in. Let's plug it into equation 2. And again, you can either use this equation 2 down here, or you can use the original one up here. I'm just going to use the original one because it has smaller numbers. It's kind of nicer to work with, right? So we have 3x. What do we get? 3x plus 4 times negative 5. 3x plus 4 times negative 5 equals what? Equals 29. Okay. So we solve for this. We get 3x minus 20, right? Because positive 4 times negative 5 is negative 20 equals 29. Going to move that 20 to the other side. So we get 49. And divide by 3, and what do we get for x? Let's do 49 divided by 3. Ooh, did I do that right? 3x plus 4y equals 29. I feel like I didn't do that right. Let's try putting it in the other equation here. Sorry, folks, I'm going to backtrack here. Going to backtrack. So let's do equation 2. let's try this. Maybe it actually doesn't work and I'm just forgetting things that I shouldn't forget. 58. So we got negative 6x plus 8 times negative 5 equals 58. What's 8 times negative 5? That's going to be the same thing. Yep, oh well. Minus 40 equals 58. Right? Yep. Okay. So, yeah, this is just going to be negative 6x equals 58 plus 40 is just 98. Negative 6, and x is equal to, in this case, I'm just going to divide everything by 2. So if we do that, 98 divided by 2 is what? 49 over 3, negative 49 over 3. So there's your solution to the system. Sometimes it won't be nice numbers like that, and it's completely fine. So therefore, the solution is 49 over negative 3, negative 5. If I did make a mistake there, you can call me out, but I'm just going with the flow right now. But that's the general kind of gist for this. So please, I hope you have a wonderful weekend, and I'll post the solutions for this on Friday for the worksheet. And that is it. We only have 2 more lessons after this, folks, and then just a final quest. Okay, take care, everyone. Bye.